Hi folks, so this video is meant to cover how you access WISE data, or at least the beginnings of accessing WISE data through URSA. The reason I've picked WISE is because it's an all-sky survey, so any place you look there's going to be data to find, and because the interface for getting WISE images is a very similar look and feel to many of the other archives at URSA. So once you've mastered that, it becomes easier to master the other archives. So from the main URSA front page, if you click on the WISE icon, you get dropped into a page that has a summary of all of the bits and pieces that URSA is serving related to WISE. There's a link to the WISE image service and a link specifically to the catalog search. There's documentation. Now, documentation can be long and somewhat boring to read, but if you're going to do science with these data, it is super useful to figure out what the computer is trying to tell you, particularly in the catalogs. If the computer is telling you that it's not sure about a particular measurement, you should not be sure about that particular measurement. So there's documentation that goes with the all-WISE release and documentation that goes with the new WISE reactivation. I'm not going to cover a ton of the stuff from the previous talk. I'm going to assume that you guys basically know about WISE, the spacecraft, and how it operates. And if you haven't watched that video, please go back and do watch that video. But this figure, I showed this figure in that other video, and I mentioned how it's pretty important. It's trying to encapsulate in one place all the different pieces of the different WISE and neo-WISE releases. Remember that we had 4 bands for a little bit more than 6 months. We had 3 bands for about 6 weeks. We had 2 bands for a little while too, and then we went into hibernation. And then it reactivated, and we have a year of data that went public last spring, and a year of data that's going to go public this spring. And for as long as there's funding and the spacecraft continues to operate, we'll keep making releases, but just of those 2 bands. The part that I didn't show in the earlier talk has more information about what is in each of these releases, because the data products vary. So there's several different releases, and there's atlas images, which means mosaics summed up or co-added of all the individual frames. And there's photometry done on those atlas images. There's also the individual exposures and the photometry from those exposures. So the very preliminary release you don't want, because it's out of date, you don't need it. The all-sky release covers all of the data taken when there were 4 bands functioning. So there are atlas images, mosaic summed up, photometry from the atlas images, the individual exposures and photometry from the exposures. For 3-band cryo, similarly, there's mosaics and exposures and photometry from the 2-band post-cryo. Note that there aren't any atlas images or photometry from the atlas released from this 2-band post-cryo era, because that data was taken under the auspices of the Planetary Sciences Division, and so they don't care about summing it up. They want the moving objects. So they want the individual exposures and the photometry from the exposures. At that time, though, we hadn't yet gone into hibernation, and there was still closeout money to wrap everything up and put a big bow on it. So that's what this all-WISE release is. It's summing up everything, all the data that had been taken to that point, making summed up mosaics and photometry from the atlas. But because you have the individual exposures already released, they didn't re-release separate exposures and photometry because it was all already released. Then when it was reactivated, it was again funded by the planetary people because they're looking for rocks that are moving. And so they don't care about summing it up. They just want the individual exposures and the photometry from those exposures. So in the more recent releases, that's all you get, the individual exposures and the photometry from the exposures. So when we go and access WISE, it's probably easiest to access it, at least when you're learning, through the image service. So let's go to the image service. Now, astronomers, almost all, work on Linux or Mac systems. Very, very, very few of us use Microsoft products. And if you are on a Windows machine and you are using Microsoft Internet Explorer, I can almost guarantee you that many astronomical tools, including this one, will not work well for you. So if your screen, especially if your screen doesn't look anything like mine, but just on general principles, you should go and get Chrome and or Firefox. They're both free. They both work better. Install those, use that rather than Internet Explorer. So when you first dropped into the WISE image service, you can search by position, meaning like right ascension and declination or target name, or you can search by solar system, object, or orbit, or you can do some more advanced searches. We're going to search by position, and I'm going to put in here M16. So look at what I did. When I first got there, there was nothing there. And it was giving me ideas, examples of how to format my request. I could put in a name. I could put in rough RA and dec in hours and degrees. I could put in coordinates in galactic coordinates. I could spell it all out in equatorial format. I could put it in 1950 coordinates. And if I put in just a name like M81 or NGC 13, I can ask it to go and get coordinates for those objects from either NED, which is the NASA Extragalactic Database, and then look at SIMBAD, or I can try SIMBAD first. SIMBAD is a service based in France. It has a huge archive of all sorts of things, not just galaxies, but NED is best for galaxies. So if you're searching on galaxies, you probably want NED. Anything else, you probably want SIMBAD. I'm going to search again on M16. So look, it has resolved the position for me underneath the box so that I can check. So for example, if I wasn't watching my keyboard, maybe I wrote only M1. So it's echoing. Is this what I think? Is this what you want? I think this is what you want. Oh wait, no, I didn't have the 6. Okay, now it has the position properly. Okay, so now we want the search type. Do we want image contains target, or image covers entire search region, image is entirely enclosed by search region, or any pixel? I think image contains target is the best option. Now return image size. If we want the full, because the WISE images are stored as tiles, and if you want the whole tile, you can just leave it blank. Or you can put in something specific, but be a little careful. If you put in the number and then change the units, it will change that number to match the units that you have. So if you want to do quick and dirty conversion, you can put in, the numbers and use this to convert it. But if you actually are paying attention and you really want a particular measurement, you probably need to specifically tell it what you want and make sure that it hasn't changed the units on you. Also, if you put in anything that's very large or very small, it will tell you, hey, wait, you can't do this. The biggest image that you can retrieve in this case is 2 degrees. So let's put in a degree. Return only the most centered image containing the target. Okay, this is a little bit sticky depending on exactly what image set you pick. So the image sets that are here correspond to the deliveries that we were talking about over here. So there's all sky, which is 4-band, 3-band, 2-band, all WISE is all of this, and then NEO-WISE reactivation is just those 2 bands for a year at a time. You can search all of them at once. But if you tell it, return only the most centered image containing the target, it will do exactly what you are asking it to do. You are asking it with this configuration, check all these image sets, but only give me one image set that is the closest to my target, or the most centered on my target. So if you do this, you might come up with some unexpected results. So for example, if you do this search, you're going to come back with only 3 bands. You're like, hey, wait a second, why is this 4 bands? Where's the 4th band? Well, the problem is that you asked it for just the most centered image containing the target, and it did exactly what you asked it to do. So if you have all of these checked, you probably want to make sure that you don't have the most centered image containing the target. For this example, though, let's leave that on, and then let's turn off all the rest of these. So we just want the all-WISE, and we just want the atlas images. You note that if I turn on one of these deliveries that has the exposure becomes an option, but if I don't turn it on, it goes away because you don't have the exposures from the all-WISE image set. So we want atlas images, all-WISE, just the most centered image, and we want all 4 WISE bands. Search. All right, so over here on the left-hand side is sort of an orientation image. That red-blue square is actually 4 squares, 1 per WISE band, and it's on top of an IRAS 100 micron image. So it's sort of giving you the landscape, right? It's giving you the context of the image. IRAS was a mission from 1983, very low spatial resolution in comparison to WISE, but it gives you sort of the landscape, the big picture. Oh, and there's other tabs here too. The details tabs gives you details about the images that we've got. Multicolor is creating a WISE multicolor image based on the channels that you have loaded here. And if you want to make it big, if you put your mouse over any of it, you see those arrows, click on that and it makes it as big as it can. You can also, it turns out that you are interacting with a 3-color fits image here. So you can zoom in and you can move the cursor around. You see in the upper right, it's telling you information about the pixel below my cursor. So really, actually very, very, very powerful. We'll talk more about that in a second. Over here, is a list of the image sets that it comes back with. So if you asked it for more than one image set, you might have several chunks of either 1 or 2 or 3 or 4 bands. Here, because I asked it for the all wise, I have 4 bands. These are all of the 4 tiles that are all part of this observation that it retrieved here. And it's telling you that 223 frames went into band 1, 223 into band 2, only 103 into band 3, and 103 into band 4. That is because, remember, all wise is all of this. So there's guaranteed to be more band 1 and 2 than 3 and 4. All right. So if we scroll down to the bottom here, we've got 4 images. And the 4 images are, in fact, the 4 wise bands, 1, 2, 3, and 4. And you can see the universe looks very, very different. When you're looking at wise band 1 or 2, it looks very different than 3 or 4. So if we zoom out, make this one fit, because we asked it for a big image, you can sort of see the context a little bit better. So you notice that when I did that, all of these changed together. They are all linked because they're all guaranteed to be of the same chunk of sky. If you don't want it to do that, you can unlock it here. But all of these are zoomed together, which is really helpful when you're trying to investigate the same target in many different wavelengths. And so you can see that it has created a multicolor view here, and it's got the 4 images there. So it's giving you the magnification here in the green at the top of all of these. And you can see that the universe looks very different, even more so among these 4 bands. So the image toolbar that's at the top here, there's lots of different things you can do. If you click on that, it will save just the currently selected one. You see the orange outline? It'll save just the currently selected one. You can zoom in, you can zoom out, you can make sure it's 1-to-1 so that 1 pixel in the image is 1 pixel in the data frame, which isn't very helpful when you have a gigantic image like we've picked. It may make more sense to zoom to fit so that it all fits in the frame. You can also zoom so that it maximizes the space left and right. You can change the color table depending on which one you have selected, although they all are linked for us here. We can change the color table. So what that is the translation between the data values in the images and the color as it appears on the screen. So if you don't like the black and white, you can pick something else. I encourage you to play around with this. There is no way that you can break anything. You're just exploring what is in these images. You can also change the color stretch. So the mathematical function that maps the real data values in the image to these colors is what is in here. So by default, I think I have it as a z-scale linear. No, apparently not. I don't have it as a default z-scale linear. Maybe it was a z-scale log. I don't know. Whatever it was. You can play around and see how this stretch tremendously changes what you're seeing in the images. And that's why you have that as a choice, because there's a lot of complicated functions you can use to translate between the numbers as they appear in the original data files and the colors as represented on the screen. And depending on what you're interested in, it might be really important to use a different stretch. So for example, here, you can see the nebulosity out here much more easily in this stretch than you can in some of the other stretches that I've picked, or you can see more detail in other places than, it depends on the brightness range in the image. It depends on what stretch you pick. So I strongly encourage you to play around with this and see what you can learn about these images. You can also rotate them. They should come back north up, so clicking on that doesn't seem to do anything because they're already north up. If you're at the telescope, it might be useful to flip it because some telescopes reverse. Flip the image as you're looking through the telescope. Of course, these are wise images, so you don't have a telescope that will get images looking like this. You can center the image again on the target that you requested. You can pick a region, click and drag, and you can crop, or you can do statistics on that image. You click again to make it go away. You can measure distances. If you click on the ruler, you can click and drag to measure distances between objects in the image. You can add an overlay of a particular target, like if you're planning observations. You can add a compass rose, you can add coordinates, you can add this. DS9 is something that I have other videos on, that is a common astronomical application for viewing FITS images. So what this is providing is a way to move back and forth between Ursa Viewer, which is what we're fundamentally using here, and the DS9 universe. And so you can choose to have it drop all of the overlays into a region file that you can then read into DS9 later on. This gets populated depending on what is being shown as an overlay on the images. So if you don't want the distance tool anymore, you can turn it off. Don't want the grid anymore, you can turn it off. Don't want the marker anymore, you can turn it off. Don't want the compass rose anymore, you can turn it off, or you can delete it entirely. So if you want to return everything to the defaults, hit that arrow, and we should return everything to the defaults as it existed when we first came in. So if you've been mucking about with scales and zooms, that might be useful. This, of course, controls whether or not all the images are locked together. This gives you information about the FITS header of the object of the image that you have selected, the image that's outlined in orange. And so this is all the stuff in the FITS header. And if you're looking for a particular FITS keyword, you can click on the top and it will sort alphabetically, so you can more easily find the particular FITS keyword that you need. Now, let's say that you want to download these data to disk and start playing with them. You can click to select individual rows, or you can click at the top to select all of them, then click on Prepare Download and say, yes, we want all bands. Do you want ancillary files? Well, depending on what you're doing, you might. Probably for just basic image exploration, you don't need all that stuff. Coverage talks about how many frames there are per position. Uncertainties are the errors in each point. Diffraction spikes, halos, optical ghosts, and latents are all image artifacts. We can talk more about image artifacts later. Do you want the whole tiles or just the cutouts? And do you want, if you have many targets, many different sets of images, do you want them all within their own directory or all at the top level? And you can say, okay, well, if you think the packaging is going to take a while, you can put in your email and it will email you the link when it's done. I'm just going to ask it to prepare download for now. It's going to spin off over here and work its magic. Now, the Catalogs tab, of course, the WISE pipeline, in addition to making images, if you recall over here, is also giving us photometry depending on the release. So if we go to catalogs, you can search the catalogs that are at Ursa. Lots of different catalogs I'll go through in a second. You can also load a catalog from disk if you have it. You can also search the virtual observatory for catalogs. For right now, let's just search the regular catalogs. Now, it pre-fills the coordinates here and the kind of search with a search that matches the search we just did. So this is the vertices of that polygon in right ascension and declination. You can also do all sorts of other kinds of searches, but let's just leave it on polygon for now. By default, it comes up asking, if you want, because you're working in WISE images, do you want a WISE catalog? So that's, makes good sense. There's lots and lots and lots of other data at Ursa, lots of other data. So you can go and search those other catalogs and overlay them as well. But for now, let's just pick WISE. And again, there's lots of different WISE releases. What you probably want is the all WISE database, because remember, it has all of the data prior to the hibernation summed up. Okay? So the source catalog is the most general catalog. If you want more information, click on the info link and it says, okay, well, here's the information on it. Multi-epoch photometry table is looking at various, variations from the individual exposures. The reject table is stuff that the pipeline said couldn't possibly be sources. And there's other useful information here that you need to read the documentation to sort out. But the WISE source catalog is probably what you want. Go and search, and it will go and ask the computer to give us that catalog. So remember that we searched over a degree. That's a pretty large area. So the catalog may indeed take a little while to prepare, but it does say that our download is ready. So if we're going to download those images, you just click on download now, and it saves it wherever your browser is configured to save files. That's going to be different for every computer, different for every system. I can't give you a global rule because it depends on how you've configured your browser, but it's probably in a downloads folder. So if I go over to my downloads file, indeed, I have a wisefiles.zip. If I double click on it, my computer knows immediately what to do with that. Your computer should know that too. If your computer does not know what that is, There's tons of free uncompression routines out there. Zip is a really common encryption form, not encryption, but compression form algorithm. So there's lots of decompression applications out there that you can find for your computer system. So it's unzipped it into a folder. It says level 3A because it has to do with exactly how it's processed. That's the tile number, not that you care, but those are the FITS files. And we didn't ask for any ancillary information. So if we drag this over to see the whole file name, that's the tile number, that's the channel, COIs 1, 2, 3, and 4. It's telling us the right ascension and declination because that's the kind of search we did, and it's telling us that it's 3600 arc seconds on a side. You can leave the files in this format, or you can straight away rename them into something that makes sense, like WISE1 M16 or M16 WISE1, M6 because M16 is more general. M16 WISE1, and then stop. M16 WISE2, then M16 WISE3, and then M16 WISE4. Okay, and then you might also want to dig it out of this deeper structure. Move it over here, and then we can get rid of those directories. So now I have the FITS files for M16, and this README file is just, a diagnostic. It's letting you know that it did succeed. So you can also throw that out. So we've got the 4 WISE files. Over here, it looks like it's completed. It found 23,000 rows in the catalog. So let's, load that catalog. So here's the catalog, and it is a big catalog. So it took it a couple seconds, but what it's doing is all that green is overlaying all of these sources in the catalog, all 23,000 on top of the image. So right now it's pretty overwhelming. Let's zoom in so that we have a much closer look, and you can see that indeed almost all the sources you can see by eye, and even some that are difficult to see by eye, have a counterpart in the catalog. And things get super complicated when you go to the longer bands because the point sources just aren't there in the same abundance. And the background has come up quite a bit too, making it even harder to find the point sources. So this is one of the really powerful things about the fact that this tool is interactive. If I want to know that source, I click on that source. It's highlighted in all of the images and in the catalog. And over here, if I click on another source, it does it again. It will work the other way too. If I click on a source here, it'll be highlighted in the images. Although, because we've picked such a big region, it may not be obvious. There's the source we picked, is way down there, right? So if I go into, let's see, the 250th page out of the 500 or so, and pick a source, right? So pick a source. It's finding other sources in the catalog. So this is super, super, super powerful because it is interactive. It has linked the images and the catalogs. And this is really important because if I'm going to pick this source, I can cleanly see it in WISE1 and WISE2, but it's a lot harder to see it in WISE3 and WISE4. So if we go and look in the catalog and scroll over, there's lots and lots of columns in the catalog. And to understand what all the columns are, you really do need to read the documentation. But W1M Pro is WISE1 magnitudes from profile fitting. So it has that star that I picked there is 6.7 magnitudes in WISE1, Vega magnitudes. There's the error, that's the signal to noise ratio of the detection. That's an estimate of how well the pipeline fit it. WISE2 magnitudes from profile fitting 6.5, error, signal to noise, chi-squared. WISE3 6.8, so it thinks that it has found a source at WISE3 that's a magnitude 6.8. So before I decide whether or not I believe that, just because the computer says it does not mean it is right. The computer is clearly less certain about it because it had a signal to noise of 50 for WISE2, but a signal to noise of 9 in WISE3. So it is clearly less certain about it, but it says that there's a source there. If I scroll over further, WISE4, look, it has a magnitude measurement but it also has no error. And if I scroll over even further, I can learn what the computer is telling me. The computer is telling me, here's the photometric quality column. The photometric quality for WISE 1 and WISE 2 is A, which means exactly what it does to you or your students. Those are good quality detections. B in WISE 3, did okay. U means upper limit. So even the computer says that it was not detected in WISE 4. It is an upper limit. So in order to understand what the computer is telling you about these sources, you really do have to become familiar with what it's telling you with all of these columns. And the columns I just laid out are pretty much the most important ones. The profile fitted magnitudes, the error on that, and the photometric quality flags, because it's trying to tell you what it thinks about those sources. You can also impose filters, which are pretty useful too. So if I click on this filter icon, boxes appear at the top of each column. Let's say I only want the ones that are really, really, really strong sources. So I'll say I only want the signal to noise ratios greater than 10 in each one of these windows. Let's see, signal to noise W3, come on, W3, where did it go? W3 SNR, W3 SNR, where did it go? W1 SNR, W3, W2, W3 SNR greater than 10, W4 SNR greater than 10. Look, it has weeded this down to 1,700 sources out of however many tens of thousands we had before, and you can see there are many fewer sources overlaid on the images. If we zoom out to make it fit, there's still a lot, but it's not the uninterrupted swath of green that was there before. So you can interactively, between the images and the catalogs, call the catalogs, select objects on the images. You can say, okay, I just want the things in here. I just want to impose the filter on that. I just want the sources from this region. So this is super useful because of this interactivity. There's lots more stuff, of course, you can do with the plain catalogs. But if you just want to save the catalogs to disk, you may or may not want to save the filtered or the unfiltered versions. Let's cancel all the filters so that it has then the original 23,000 sources. If I click on the diskette icon, it saves it to disk wherever my browser is configured. And because the software under the hood that it's using is called Gator, the table file, which is just an ASCII file, it's an IPAC table, it's just a kind of ASCII, is saved as Gator query.tbl. So we'll talk in another movie about what to do with the catalogs and you know, tricks to impress your friends with the catalogs. If you want to make the catalog go away, hit the blue X and it goes away from everything. You can search for more than one catalog at a time. So you can, of course, also search in other ways. You can search for a list of objects. You can search for a single object at a time. You can also search for solar system objects. You can go through and say, okay, I want this particular comet over all times, and I want, let's see, all of the data that I can get, and just in WISE 1 search. Now it's going to come back with a similar interface but different, because you see it's getting these single exposure images, and that's important because when you sum up the images of the stuff, you know, like in all WISE, that gets rid of the moving objects. But this comet is a moving object, so you want the individual exposures. You don't want the summed up images. So it's come back and it's given us an orientation image here, just like it when you do a search on a right ascension and declination, but now it's showing us where along the ecliptic plane there are observations of 67P. It's, you know, this is a galactic projection from Derby, and so this S is the plane of our solar system, and so this comet is only found in the plane of our solar system, and it was found in three different chunks of time. It will also show you where it was in the orbit when the observations were taken, and that's a multicolor image assembled from the individual exposures. So over here, these are the individual exposures. The box is where it is in this frame. And the X's are other apparitions from other search results that it found. So you can also return the view to something similar to what it had when we were doing the search before. Only, as I said, these are the individual exposures, not the individual channels, because that's what we asked it to do. So one thing you might want to try is for at least one or two Messier objects of your choice, or NGC objects if that's what you prefer, go and see what it looks like in WISE. Go and get the images. If you feel like it, go and get the catalogs too and play around with it. See if you can figure out what the brightest thing is in the images that you return. You're going to have to figure out what the best size of the image is that you should ask for, and what the best delivery is that you should ask for, and have at it.